Okay, here's your 8.4 notes. You have two essential questions today. First one, how do you multiply rational expressions? And the second one, how do you divide rational expressions? So you should be answering these two essential questions in your summary, and you should be able to answer them after notes today. So if you need to pause while you copy those down, go ahead. Okay. So next, when is a fraction undefined? So go ahead and pause and see if you can come up with when would a fraction be undefined. Okay, so a fraction is going to be undefined when the denominator equals 0 because we cannot divide by 0. And so I don't know if I've shown you guys this before, if you've seen this before, but remember that it is okay to have a 0 in the numerator because 0 divided by a number is going to equal 0. So that's okay. But it is not okay to have a 0 in the denominator because you cannot divide by 0. This is when a fraction is going to be undefined. Okay, so a fraction is undefined when the denominator equals 0. So for example, if I give you this, what is, excuse me, a restriction for x? Well, we can't let x equal 0 because if it did, then this would be an undefined fraction. So since x is in the denominator, that means that x cannot equal 0. X can be any other number in the real number system, it just cannot be 0. This is what we call a restriction on the input or a restriction on the domain. Okay? So, now we're going to learn how to simplify rational expressions. And a lot of what we do today should be reviewed from Algebra 1. It was towards the end of Algebra 1, so hopefully your teachers were able to get to that. Okay, so first, factor both the numerator and the denominator if possible. So that's your very first step to try. Next, we're going to find the restrictions. Okay, and I'll show you what that looks like. But again, finding restrictions, you're only focusing on the denominator because it's the denominator where we can't have a 0. 3, we're going to cancel out like terms, and so I'll show you what that looks like. And 4, once we cancel out the like terms, whatever is left over, that is going to be our final answer. So if you need to pause, go ahead and pause while you finish writing those down. Okay, so let's work out number 1a together. So simplify each rational expression, show your work, state the restrictions on the domain. Okay, so first step is to factor the numerator and denominator if possible. It is possible here. So notice we have a trinomial on top. So we can actually factor this into 2 parentheses, and we can use the shortcut because there's a 1 in front of x squared. So then you're asking yourself what multiplies to give you negative 15 and adds to give you the negative 2. So what would that be? Okay, so hopefully you're saying x minus 5 and x plus 3. Because negative 5 times 15, or I'm sorry, negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. Then remember the denominator here, x squared minus 9, this is difference of squares, where you can square root both of these. And so you'll have x plus 3 and x minus 3. They need to be opposites so that the middle term cancels out. That's why there's just a binomial here. So that's your first step, is to factor both numerator and denominator if possible. Next is to find the restrictions. And remember, the restrictions come from the value of the denominator, because we can't let the denominator equal 0. So to do the restrictions, I'm going to take each of those parentheses and set them not equal to 0, because that is what they cannot equal. They cannot equal 0. So then I'm going to go ahead and solve. So minus 3. So then one of my answers is that x cannot equal negative 3. And if you solve over here by adding 3, then that answer is that x can also not equal positive 3. Now you could have written this as a plus minus 3 instead of writing it separate like this. So then on your homework, this is your restriction part. Now it'll either write out restrictions like this, or it'll say RES for short. So then you would write x cannot equal positive or negative 3. So x can be any other real number except for those two numbers, because if it was one of those two numbers, it would make your denominator 0. Okay. Third step, cancel out like terms. Notice that you have an x plus 3 parenthesis and an x plus 3 parenthesis on top and bottom of your fraction. So whenever there's multiplication between these two terms, you can go ahead and cancel those out. So that's step 3. That's what that means. And so step 4 is to write whatever's left over. So then on the answer line, or it may say ANS for short, is going to be x minus 5 over x minus 3. Now you can actually write this without the parentheses if you wanted to, so that it would look like this. But if you do that, please realize that you cannot just cross out the x's and say that the answer is positive 5/3, because you would have a negative over negative. That doesn't work that way. So just know that if you see an addition or a subtraction sign, that means there are invisible force fields or invisible parentheses around those, so you cannot penetrate those. You can't just cross out those x's. Okay? So then that's it. That's your answer and the restrictions. Okay? So it's important that you do the restrictions before you start canceling things out, because once you cancel it out, and you just have this, then you're going to miss one of your restrictions if you just base it off the final answer. So you'll get it wrong. Okay? All right, so let's look at example 1b. So simplify. So here, there's nothing to factor, so I don't need to factor the top or the bottom. So then I'm going to go right to doing my restrictions. Well, I would set this not equal to 0 because it can't equal 0, and then go ahead and solve, so minus 5. So then my restriction would be that x cannot equal negative 5. So x can be any other number except for negative 5. Okay. Now, third step is to try and cancel some things. Now, please, 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 and your Algebra 1 teacher would be very, very sad if you tried to cross out the 5s and say that your final answer is 1 over x. That does not work. Okay, you have 5 on top and then an x plus 5 on the bottom. Remember I said if you ever see a plus or a minus sign, those are parenthesized. Okay, those have invisible parentheses around them. So go ahead and put the parentheses around them to make it known. Then realize you can't cancel this outside 5 with this inside 5. So this is actually your final answer because you cannot go any further than that. And you're done. Okay? Alright, so that's if you have a single fraction, that's how you simplify it. Now, let's move on to how do you multiply rational expressions. So I've got some steps for you to write down to remind yourself what to do for your homework. First, again, we're still going to factor, but now you're going to have more than one numerator and more than one denominator. So factor everything that you can if possible. Second, we're going to find the restrictions on all the denominators. So now you're going to have more than just one denominator to find a restriction on. So you find a restriction on all of your denominators. Step 3, we still cancel out like terms. We can cancel them up and down in the same fraction like we did before. But then since we have multiplication, we can also cross cancel. So you can cancel on the diagonals when you have a multiplication problem. And then after you cancel, we're still going to write over whatever's left as our final answer. Okay, so if you need to, go ahead and pause this so you can finish writing down those steps. Okay, so example 2a. So notice now we have two fractions and we're multiplying them. So we're still going to state the restrictions. Instead of simplify, it may say perform the indicated operation, or it could still say simplify, so you would still do what I'm going to show you. So first, part 1 or step 1 says to factor. Well, since each of these numerators and denominators are what we call monomials, they're just single terms. So 8x to the third times y, that's all one term. That's what we call a monomial. There's nothing to factor. So step 1's done. Step 2, find the restrictions on all the denominators. So the nice thing about that is if you only have monomials, then that means your only restrictions are going to be 0. This one, however, since we have more than one variable, I have an x and a y. So then I have a restriction that x cannot be 0 and y cannot be 0. Okay, so x and y can be any other numbers except for 0. Okay, so that's your restrictions. Step 3 is to cancel out like terms up and down as well as on the diagonals. So what I'm going to do is I'm going to simplify each fraction separately, and then I'll go ahead and try and cancel on diagonals. So looking at this right here, I'm going to divide 8 divided by 2, which is 4, and then the 4 is going to go on top because that's where the bigger number is. X to the third over x to the first. Remember, you subtract the exponents, so that'll be x squared left over on top. Y to the first on top, y to the second on bottom, so you subtract, and then there's a leftover y on the bottom. Okay, so I just took one fraction and simplified it. Now let's do the same thing with the second fraction. So 4 doesn't divide into 7, so I'm going to keep that 7 over 4. 7 and 4. I don't have any x's on the bottom, so then that just stays x to the fourth. And then y to the third over y to the first becomes y squared, and the leftovers are on top. Okay? Now I'm going to look to see if I can simplify on the diagonals. And I can. Let me change colors here. So on this diagonal, I can cancel out the 4's because 4 divided by 4 is 1. So you could put a 1 there if you'd like on each one. Okay. On this diagonal, you have a y to the first and a y to the second. You would still subtract those exponents because they're on different levels. So that y is completely gone, and then you just have one y left there. Okay, so then my answer is going to be whatever's left over. So on top, I have 1 times 7, which is just 7. X squared times x to the fourth, that's when you add the exponents. We can't cancel those because they're on the same level. So that becomes x to the sixth. And then we have y to the first left, and then there's nothing left on the bottom. So then your final answer is 7x to the sixth y with those two restrictions. Okay? All right, so this is the end of this recording, so go ahead and stop it and click on video number 2 for 8.4 notes.